All right, when we left off yesterday, we had graphed our parent functions, we'd reflected, we've translated, we've done the transformations on the sine and cosine graphs, okay? Transformations, reflections, translations, we're sliding those things. And we worked on those with sine and cosine yesterday. Today, we are going to take a look at what happens when we work on those transformations with tangent graphs. Our transformations with tangent graphs. Now, the pattern is very similar to what you did yesterday with sine and cosine. So, the book gives you two methods. I'm going to tell you the method that I use every time. So the first thing I like to do is graph that parent function. Now, yesterday we know that our parent function was y equals a cosine of bx, or y is equal to a sine of bx. Today our parent function is going to be y is equal to a tangent of bx. So applying these to tangent. All right, after we have graphed our parent function, we want to, it is easiest if we do the reflection second. And when or what affects if there's going to be a reflection? The A, absolutely. If the A is negative, there will be a reflection over the line that goes through the middle of that graph. If we do it right away, it will always be the x-axis you are reflecting over. All right, third thing I want to do is I want to shift it, I want to slide it, I want to translate it left or right. And we translate left or right by K. H, absolutely. We are translating left or right by the H value. You're looking at your H value to see what it goes left or right. And last but not least, what do we finish up with? Yep, we want to see if we shift it up or down, if we translate it, if we slide it up or down by the K value. Absolutely. By the K value. So, process is the same as yesterday, but we certainly know that tangent is his own creature. Tangent is definitely his own creature, so we need to make sure that we can apply these same rules to our tangent graphs. Anybody have issues with that? All right, everybody's with me? All right, so I'm going to adjust one off of your notes today so that we can take a look at what happens in all of our situations. All right, the situation that I want to look at today, is y is equal to negative 2 tangent of the quantity x, subtract pi over 2 plus 3. Very close to the one that is in your notes, but just a little bit different with the plus 3 in the back. All right, now, really want to make sure that when I draw my graph, I give myself plenty of room. Remember, I'm moving these around, so I can never be sure where it's going to move or how far it's going to move. So, all right, what is the first thing that I am looking at? All right, okay, I got to let's take a look at our parent function. Okay, what is my parent function going to look like in this one? Okay, and you know what? You can it's everything through the x. You don't even really have to worry about that negative. I know yesterday we talked about not thinking about that negative to until the reflection, but you can take it right along. Y is equal to negative 2 tangent of x. Y is equal to negative 2 tangent of x. Now, remember that that's like y is equal to a tangent of bx. Now, what number's in there for a? A is negative 2. What's in there for b? A 1 in front of that x. Beautiful. All right. Now, a makes me think of amplitude. What do we know about amplitude? What do we know about amplitude? Okay, what, Chelsea? There is none. What kind of graph am I in? Tangent. Tangent has No amplitude because it does not have a minimum or a maximum value. Now, does that mean I don't have a use for my A? No. We still use our A value, right? We still know that it is very important that there'll be something special that happens when I go up 2 on my graph or when I go down 2 on my graph. Something very special will happen in those two places even though there is no amplitude with tangent. All right, what does the B value help me with? The period. Okay, how do I find the period for tangent? Pi over absolute value of B. You got to know these details. Pi over the absolute value of B. So pi over the absolute value of 1 is pi. Okay, do I put that on my graph? No. Really, if that period is pi, what is that telling me? For a tangent graph, if my period is pi, what is that really telling me? Beautiful. The distance between the asymptotes is pi. The distance from one asymptote to the next asymptote is pi. Now, with that said, I don't put that on my graph, but that helps me find what important thing? The period is pi. What does that help me find? My vertical asymptotes. Okay, so I need to find those vertical asymptotes. How do I find them? Okay, yep, one way to look at it is pi over 2 absolute value of B, but it's really always a half of the period. It's always a half of the period. That's the way I just make it. It just seems like easier to remember. So a half of the period, so half of pi is pi over 2. So vertical asymptotes, we're looking at vertical lines my graph approaches but never touches. I'm going to go to the left pi over 2 to get to one vertical line. I'm going to go to the right pi over 2 to get to the other vertical line. When we're thinking about vertical lines, what little thing comes to my head? Vux. Vux. I know the equation needs to be x equals a number. So it's going to be x is equal to negative pi over 2 and x is equal to positive pi over 2. So in other words, on my graph, if I go to the right pi over 2 and if I go to the left pi over 2, those are the spots that I'm going to have those vertical asymptotes. Remember, they're dashed lines. My graph approaches that line but never touches it. All right. Now what? Am I good? No. What do I need? I need some points. Absolutely. I need some points on this graph. Now, what points do we have? 0, 0. Gotta love 0, 0 tangent. The parent function always goes through 0, 0. Fantastic. All right. Is that good enough? I don't think so. Where are some other points? Okay, yep, at a quarter of p. At a quarter of p. So a quarter of pi is going to be pi over 4. Now at pi over 4, where will I be? Okay, start out with the most basic thing before you move it. So at pi over 4, I should be at positive 2. Now, at negative 1/4 of p, at negative 1/4 of pi, at negative pi over 4, where will I be? Negative 2. Okay, so pi over 4 is going to be halfway between 0 and pi over 2. And then negative pi over 4 is going to be halfway between 0 and negative pi over 2. All right, so pi over 4, I'm up at 2. Negative pi over 4, I'm down at negative 2. So we can see this very basic tangent snake curve in between those vertical asymptotes. All right. What's the next thing I need to think about? All right, is there a reflection? Why is there a reflection? Yep, A is equal to -2, so A is negative. So, it reflects over the x-axis. All right, now, my vertical asymptotes, are they going to reflect? Is it going to change anything with my vertical asymptotes? No, my vertical lines are going to remain looking exactly the same. All right, if it's 2 below, it moves 2 above the x-axis. On the x-axis stays there. 2 above the x-axis moves to 2 below the x-axis. So, up and to the left here, down and to the right there. All right, perfect. Moving along just fine. What comes next? All right. I would love to slide left and right. Now, am I going to be doing any sliding left and right? Yes, absolutely. What am I going to be moving? Or how am I going to be sliding? All right, minus pi over 2 means that my h is a positive pi over 2, which means that I'm going to be sliding to the right pi over 2. Now, just a comment. If I am moving to the right pi over 2, if I'm moving to the right pi over 2, am I adding or subtracting pi over 2? Adding. And there are 5 key places on my graph that I need to add that pi over 2. My asymptotes as well as my points. So, my asymptote right now is at negative pi over 2. My point's at negative pi over 4. My point is at 0. The next point is pi over 4. And my next asymptote is at pi over 2. And I'm moving to the right pi over 2. So I realize that I'm going to add pi over 2 in every case. All right, now just a comment. No criticism to anybody, but we're making too many mistakes with these silly little fractions. So, what's negative pi over 2 and pi over 2? Negative a half and positive a half is 0. All right, negative a quarter of pi plus a half of pi. What's negative a quarter and half? 1/4, which is pi over 4. All right, 0 plus pi over 2. Pi over 2. A quarter of pi plus a half of pi. Good. 3/4 of pi, which is 3 pi over 4. Beautiful. And a half of pi and another half of pi is a full pi. All right, now I always like to back up and see what's on my graph. So 0's on there, pi over 4's on there, pi over 2's on there. 3 pi over 4 is not. So, and go to the right there. Got to add 3 pi over 4. And pi is not, so I'm going to go to the right of 3 pi over 4, and I'm going to add a pi to my list. All right. Now, everything is going to shift to the right, pi over 2. So what used to be at negative pi over 2, the vertical asymptote that was at negative pi over 2, is now going to be at 0. So, I got a vertical asymptote now, right at 0. Okay, at negative pi over 4, I was up at 2. So now at positive pi over 4, I'm going to be up at 2. All right, at 0, I was at 0. So now at pi over 2, I'm going to be at 0. At pi over 4, I was at negative 2. So now at 3 pi over 4, I'm going to be down at negative 2. And at pi over 2, I had a vertical asymptote. So now at pi, I'm going to have that same vertical asymptote. All right, and we can see our snake curve for tangent right there. Perfect, perfect, perfect. All right, am I done?
No.
Why not? All right, got to think about shifting up or down. Am I doing any shifting up or down?
Yes.
What am I doing?
Up.
Beautiful. This plus 3 means that my k value is 3, so I will be shifting everything up 3. Now, what I like to do is I like to take probably the highest points there and see where we're at. All right, so my top point here is at 2. So if I go up 1, 2, 3, let's see, 3, 4, 5. All right, now vertical asymptotes. If I shift them up 3, is it going to do anything? No, my asymptotes are going to stay right where they are. So I like to darken them in so that I know where the final asymptotes end up. All right, so up 3 with my point here, up 3 with my point here, up 3 with my point here, and there's my tangent snake curve right there. And I always like to mark final by it so that I know that that's my final graph, the one in the red. Colors really help. Now, do not forget, I am going to continually ask you the same questions over and over and over. What is the amplitude of this graph? None. Tangent has no amplitude. It has no maximum or minimum. All right. What is the period of this graph? The distance from one asymptote to the next asymptote is pi. All right. Are there any asymptotes? Where are they? All right, x is equal to 0, x is equal to pi. All right, how about my domain? Okay, now just a comment. Yeah, I like Brooklyn's thinking. We can have anything we want except where those asymptotes are, right? So we got to think, where are those asymptotes? Okay, be careful. Be careful. 0, pi. Where would the next one be? 2 pi, 3 pi. Is it always odd multiples? It's all multiples of pi. Any multiple of pi in this case, right? It's going to be any multiple of pi because our period is pi. It's going to depend on what your period is. So because my period is pi, it would be 0, pi, 2 pi, 3 pi, 4 pi. So x does not equal multiples of pi. Yes?
So like, for when you translate it, it could be like anything about it, but then when it's just graphing it without the translation, it's always going to be on practice. Whatever the
This includes any of the additional cycles that we could draw. Yes. Does that make sense? All right. What about my range? All reals. My tangent always has a range of all reals. Anybody have issues with that? Do we feel pretty comfortable? I mean, the process is the same as yesterday, but tangent's a little sticky. It's a lot of mess going on in there. Any questions on that? All right, then let's continue here. If you would, I'm going to skip to the last page on the notes for those of you that are moving along with that. We are going to be looking at writing an equation of the graph described, okay? And you had a little bit of practice on this on the homework. Writing the equation of the graph described. Now, the graph is going to be y is equal to sine of 2 pi x. They translate it down 5 units and right 2 units. Any thought about what we're thinking as we see translated down 5 units and right 2 units? Yep, Ben? Okay, what values? Okay, careful, careful. I went down 5 units. All right, so my k is going to be a -5. Right 2 units. My h is? What is my h? 2. My h is a 2, but I know what you're saying because what's our equation going to look like? All right, it's going to be y is equal to sine 2 pi, and in parentheses we're going to have x minus 2 minus 5. Here is right 2. Here is down 5. All right, let's try the next one and see if anybody can tackle that one. The graph of y is equal to 1/2 cosine of pi x, translated down 3/2 units. So first they shifted it down 3/2 units and left 1 unit. And then they flipped it over, so they had to reflect over the line y equals negative 3/2. Because they did it in a different order than I do. First they shifted down, then they shifted left, then they reflected. Little different order than what I typically do. Nothing wrong with that. What is the equation for that situation going to look like? Okay, y is equal to, I like the negative 1/2. That shows the reflection. Cosine of pi. All right, left 1 means that my h is a negative 1, so it's going to be x plus 1 in parentheses. Minus 3/2. If I go down 3/2, my k is negative 3/2, and the reflection means that the a is negative. Questions with that?
What about the y equals then reflect in the line?
Okay. All right. Here's the deal. This cosine, if I made a little sketch of this, okay, this cosine right here, this parent function, means I go up 1/2 and I go down 1/2 and I do cosine, which we know starts at the top, goes all the way to the bottom, all the way back to the top. That's just a really general sketch of it, correct? Now, oops, sorry. Okay, now, they translate it down 3/2, so down 1.5. Okay, so now it's right here, and then they shift it left 1. Okay, so if I shift it left 1, it's going to be over here. And I don't know if this is accurate or not, but it's going to be over left 1. And then they reflect. Now, when we do our reflection, we reflect first. So that means I really reflected over the x-axis, correct? But they shifted this down 3/2. So if they shifted it down 3/2, that means that that x-axis shifted down 3/2 also. So this is y is equal to negative 3/2. The line that cuts through the middle of that cosine wave. Normally, the line that cuts through our parent function is the x-axis, y equals 0. But when we shift it down, now it's y equals negative 3/2 that cuts that cosine graph in half. So they flip over that line. So that means that instead it's going to look like this. Little bit different order than I do it in. I do my flip first because I like to reflect over the x-axis. We make fewer mistakes. They did it at the end. There's nothing wrong with that. Does that make sense?
Okay, well what if the y, like you wanted to reflect it over what you did to it down? Like say you wanted to reflect it over +7.
We are only reflecting over the axis that cuts through the middle of the sine or the cosine wave. Okay? Yeah, we're not going to, you can't adjust your equation to reflect over some random line like y equals 10. Does that make sense? Great questions. Anything else? Okay.